So it says that 3 light bulbs of 30 watt, 50 watt, 40 watt and 50 watts are connected to a 120 volt power supply in series. Each bulb is rated 120 volt. How much power each bulb is absorbing? We need to find that out. So we have a power supply here of 120 volts and 3 bulbs are connected here. So like that and then like that. 3 light bulbs are connected. This is 30 watt, this is 40 watt and this is 50 watts. So we need to find how much power each bulb is absorbing. So what we can do, first we can find what is the resistance of each of the bulbs, because each of the bulbs rating is given. 120 volt is the voltage rating and power rating is 30 watt or 40 watt, 50 watt, whatever, depending on the bulb. So resistance of the 30 watt bulb will be P is equal to V square over R. So R will be equals to V square over P. So that will be 120 square over 30 and we will get 480 ohms. Similarly, R40 is 120 square over 40 and that's 360 ohms, 360. And R50 is 120 square over 50 and we are getting 288 ohms. So these are the respective resistances of the bulbs. Now we need to find what is the power, what are the powers absorbed by each of the bulbs. So P30 will be, before that we need to find actually the current. So we have the resistances of each of the bulbs. So we can say here that this one's resistance is 480 ohms, 360 ohms and 288 ohms. So we have 3 resistive elements, let's say, connected in series with a 120 volt power supply. So we can find what is the current that will flow through the circuit. So the value of the current will be I equals to 120 divided by 480 plus 360 plus 288, 360, 288. So current is 0.106 ampere. So that's the current. Now we can find the power absorbed by each of the bulbs. So P30, if we talk about the 30 watt bulb, so that will be I square R. So I is 0.106 square and the power will be, resistance will be the resistance of the 30 watt bulb, that is 480. So power dissipated, absorbed will be 5.432 watt. So we can see that the power it's absorbing is much less than its actual power rating, which is 30, and as a result the illumination will be much less because it's not absorbing sufficient its power up to its rating. P40, let's see what happens to that. That will be 0.106, again I square R, 0.106 square times 360, and that is 4.074 watt. So this is also much less. It's 40 watt bulb and this is actually absorbing even less power. And then finally 50, P50, that will be 0.106 square times 288, and this one we are expecting it will be even less, and that's what's happening, 3.259 watt. So they are absorbing much less amount of power, and the reason is the voltage drops across each of the bulbs is much less. So the voltage drop across each of the bulbs is much less. We can find the voltage, all the voltage drops. So the voltage drop here will be V is equal to IR. So 0.106 times 480, that's 50 volt, much less. As a result, the power it's dissipating is much less as well. And similarly we will see that the voltage drop across 40 watt bulb, because this one's resistance is even less, so the voltage drop will be even less. And for the 50 watt one, 50 watt one will be the least amount of voltage drop, because resistance is 288 times 0.106. It will be much less. It will be approximately 28 in that range. So this is happening because all three bulbs are connected in series. They are not getting the full their rated voltage, though the supply is 120 volts and their ratings are each of the bulbs rating is 120 volts, but they are not getting that voltage, and that's happening because they are connected in series. So if they were connected in parallel, this is what happens in practical cases. So if they were connected in parallel, all these bulbs, then each of them would get full 120 volts across, right? So this would get 120 volts, this would get 120 volts, this would get 120 volts, and they would illuminate. Their power absorption would be accordingly 30 watt, 40 watt, 50 watts, and the illumination will be appropriate. So yeah, this problem actually shows why bulbs loads are connected in parallel.